5,400.
He's
Give it a second. All right, so we are on tension.
Has this all been recorded?
All right.
Hold
What'd you say you're at?
53.97.
Oh, you played yesterday.
And
You played yesterday. You were at 5,200.
Are you stalking
No. All right. I'm at 49.67.
Are you playing Clash Royale?
That's what we're talking about.
All right.
I know. Well, I didn't actually.
All right. So tension. Tension.
Wait, I found the cow. Wait, found the cow.
That's Julian.
Julian's hanging
Oh, I
out.
thought it was in.
Yeah. That's
Wait, did you find number one?
No.
Jacquees, no.
All right, guys, we got to get through this.
All right.
All right. Force that is transmitted through a string, rope, cable, or wire when it is pulled tight by forces. All right. Did I show you guys the tug of war competition?
Yes.
Yeah, it's amazing. All right. A lot of tension in that rope. All right. Let's see. When it's pulled by forces acting from opposite ends, the tension force is directed along the length of the wire and pulls equally on the objects. So it pulls equally on objects. Okay. So let's say, that's kind of hard to read. Let me make that bigger. Maybe pull this down, would that help? Maybe all of the above. Do you want to know something? I got an even better pencil sharpener than that.
Really?
Yeah, it's over there on that side.
What is this favoritism?
Got two.
I can reach this one.
I know, but that one, I kid you not, is the best one I've seen.
I'll try it next time.
Yeah, absolutely. All right, so if I am pulling on a rope and Andrew's pulling on a rope and we pull and neither one of us is moving, the force of tension on my side is going to be equal to the force of tension on his side. That is awesome. Like, honestly, that's pretty cool.
What's the rope's name?
Oh man, I was hoping to come up with like a really clever name in that moment of time, but now I can't go back to like 2 seconds ago and think of a clever name. I'm sorry.
You still just. You've had to name so much stuff this year.
By a 16-year-old.
I can't blame.
Jacquees, I thought he was trying to do that.
Man. I was gonna call it Snake, but
Well, you were gonna name it Snake.
yeah.
Say it out loud.
All right.
Yeah, do it.
Any questions on that? All right. So, static equilibrium. Did I have you guys write this? I did. Okay. Static equilibrium is a state where no acceleration occurs. Okay. No acceleration occurs. All right. And we're going to analyze that a decent amount in tension. Okay. Anytime we construct bridges, build houses, we want them to stay stationary as distant as possible. Okay. All right. So, why is that off a little bit? Wish I could call. Oh, there we go.
Getting better, getting closer. Good.
Yeah.
Good.
Oh.
Oh, too far.
That's good though.
It was perfect. You had it.
Now it's crooked. You can't read it if it's
Warmer.
Tilt it a little
Tilt
bit.
it to your left, up, up.
Tilt your head's
up.
left and up. That's good.
I'm
That's
gonna
good.
be dizzy this whole time.
Up, down, left, right.
All right. So, what will tension force of a string if it's hanging 1 kilogram attached to it? All right. So, if we look at this type of problem, what is the tension of a string if you have? Absolutely. How was it?
Amazing.
That is, look at that. Look at that.
Look at that.
Show that around.
Oh my God.
Show that around.
Dude, it's godly. It is godly.
Check that out.
It's designed to do.
All right, I need one
It's
pencil.
insane.
Check that out.
Wow.
Absolutely. I understand. All right. So, if I have a 0.1 kilogram mass hanging on a string, all right, the only force acting on it is gravity, right? If it's hanging here, the only force is gravity. So the force of tension is equal to the force of gravity. Well, the force of gravity is equal to the mass times the acceleration due to gravity. So what will the tension force of a string that is hanging with 0.1 kilogram mass? 0.98, but 1 unit, so 10.
Oh, yeah.
So 10
I hate sig figs.
or
1.
or 1.
One.
0.98.
I hate the
Round to
orange.
1. That's right. Okay. All right. So will the tension force be greater, less than, or equal to if you have the same mass but hung with 2 strings? It'll be less, right? Because the tension will have both. Like so, this will be half the tension. That will have half the tension. Okay. If you attach 2 1 kilogram masses to a pulley while the system is in equilibrium, all right. So here's your point. All right. What will the tension force be? So both of them are pulling down. They're the same mass. So all you got to do is look at the tension of one side of it. So it's going to be 1 Newton again.
Yeah.
There's 2 newtons total, yes. However, this tension is 1 Newton. This is 1 Newton.
Oh, okay.
So
I
what will the
sounded
tension?
really confident. I'm feeling pretty stupid right
No, you're good. You're good. All right.
It's okay.
Look at these tension. A monkey. I just kind of felt like putting that on there.
Oh.
Like, who doesn't want to see a monkey? Just brightens your day. Honestly, this is the best example, though. Look at that. All right. Triple pulley system. The tension is divided among 6 different wires, and that's why they're so strong. All right. All right. Here we go. Number 28. All right. So a 5 kilogram mass is hanging from the ceiling. Okay. What is the tension of the string? All right. So I'm going to draw it out right here. All right. So I got my string. 5 kilogram mass. All right. What is the force? Let me zoom in. What is the force acting on it? Gravity. Is that the only one?
Yes.
Yeah.
Absolutely. So let's see. The force of gravity is equal to the mass times the acceleration due to gravity. So 5 times 9.8. I think I need a calculator. 49. So 1 sig fig, 50 newtons of force. How's that for tension?
That was pretty easy.
Not bad.
3 times.
Not bad.
You were waiting for that.
This is handled better.
All right. So let's see. If someone grabs a string and pulls upwards, so it accelerates at 5 meters per second squared, what will be the tension in the string?
Wait. If
Okay.
you pull it upwards,
If you pull it upwards.
that
Right.
upwards is towards the ceiling.
So if you look at
You're
this,
sitting in the ceiling. just
the
like-
only force, since it's not moving,
Ceiling tiles.
it's not moving, guys, the only thing we have to look at is the sum of forces in the y direction. Oh my gosh. The sum of forces in the y direction. Are you done? Rock star.
Good job, buddy. Good job.
I'm just doing this. All right. Sum of forces in the y equals mass times acceleration in the y. So, what are my forces now? I have force of gravity, but then I also have, but then I also have the force applied. I'm pulling it upwards, right? I'm giving it tension up here, right? So the force of tension is pulling it up, right? The force of gravity is pulling it down. The mass was, what was our mass? 5. And what's the acceleration I'm pulling up with?
Oh, you are drawing it so that it would be applied to the block, but it says it's applied to the string above the block.
It is.
So are we
So it seems like you're just pushing the block upwarding.
Are we measuring
It
the
is.
tension above where you're grabbing it?
You
or
are.
below?
You're where it's at. So theoretically, it would be here. The force of gravity, force of tension.
So wouldn't you add the forces?
No.
No, they're going in opposite directions.
Yeah, but it's measuring the total tension.
Right.
Force of opposite direction.
So the force of tension is going on the string up. Right? You're pulling up. Force of gravity is pulling it down.
Force of gravity is no force.
Okay? So what's the acceleration I'm pulling at in the problem? This thing says 5. Okay? So force of tension minus, what's the force of gravity? I solved that earlier. Is equal to 25. What's my force of tension in this problem? Bada bing, bada boom. How do we feel on that?
Good now, just wait until the end of the class period. That's when we'll have a true answer.
No, we're gonna be good. We're gonna be good. Any questions on that problem? All right, let's try another one. Uh-oh. Double. We're hitting the double. All right. If mass 1 equals 5 kilograms and mass 2 equals 7, what is the tension in each of the strings? But not that bad. Okay, so I'm going to draw it out. Okay, so here is my first mass, okay? So that's going to be the 5 kilogram one. 5 kilogram. Coming down. Okay.
Your
There's
pencil
my-
lead is so dark.
7 kilograms. Say what?
Your pencil lead is so dark.
Thanks. What is the tension of each string? Okay. So we have to look at all my forces. Well, let's look at this bottom string. All right, so I got the force of tension. You guys see that? I might zoom in a little bit. So I got the force of tension, but then I got the force of gravity. I'm going to say the force of tension box 2. This is box 2. Force of tension 2. Force of tension 2. Okay? However, if we look at the top string, same thing, it has the force of tension 1, force of gravity, but what else is pulling on it?
Force of tension.
Force of tension 2 is pulling it down.
Um,
Does that make sense? This string is only affected by this mass, but this string is affected by both masses. Does that make sense? Okay. So let's solve them. Okay. Which one do you want to do first? You want number 2? Okay, let's do number 2. Number 2 seems pretty straightforward. So the force, let's see. Number 2, so the sum of forces equals mass times acceleration. All right, so I got to look at the sum of forces, and the y is equal to mass times acceleration. All right, so I need to solve for my force of tension. Gravity is fighting against me, so what's the force of gravity on this object? 9.8 times 7. We'll just put it 4. Okay. Does that make sense? I just got the force of gravity. Any questions on how I got the force of gravity? Mass times 9.8. So that's my So that's equal to the mass, which is 7, times the acceleration in the y. Is it moving up or down? No, it's just hanging there. So the acceleration is 0. So what's going to be my answer?
68.
It could be, well, that's 0. So 68, 60. Oh, 0. 0. So it'd be 68.6.
It's 7. It's 7. Oh, what? Go on.
60.
Sorry.
Wait, could you technically do just that the force of tension is equal to the force of gravity and then just say 7 times 10.8 and get 70 divided by 10
I caught that. Yeah. Okay. So that's the force of this block. Okay. Now we got to do the other string. Okay. The other string. So we got to look at all our forces. Force of tension 1 minus the force of tension 2 minus the force of gravity is equal to the mass times acceleration. Okay, here we go. Force of tension 1, I do not know. Minus force of tension 2, well, I just solved that. That makes it easier. That was 70, or 68.8. I'm going to use 70 because that's easy. Minus gravity. So gravity is going to be 5 times 9.8. So that's going to be close to 50. Oh, my screen froze. All right. So I'm going to say 50 is equal to the mass times acceleration. So the mass times, what's the acceleration again? 0. All right. So what's our answer going to be for the force of tension 1 up here?
So for the mass, would it only be the top box or would it be both of them since both of them are in?
In this one, it's only the top. Yes.
So instead of like doing all of that, I just did the force of tension 1.
Yep.
Equals like mass times acceleration, and then put mass is 12 because that's the total mass it's carrying, and then times that by 9.8, and I get the exact same answer. So is that like right to do?
So you did the force of tension is equal to the mass of the total mass times the acceleration. You could do it that way. Yes.
Okay.
All right. So force of tension 1 is 120. Oh. How do we feel on that? So tension's all right. All
Page and a
right.
half left.
So what?
Page and a half left.
Oh, we only got like 2 more problems I want to get through.
Oh, okay.
That's it.
And then Clash Royale.
Clash Royale. Okay. Here we go. This is where we start to get in. We're gonna apply everything we know about tension, about physics, about life, everything.
What is the meaning of life?
The meaning of life.
What do we want to do?
That's a great question.
To leave the world a better place for us.
42.
Okay. So let's see. To hang a 6.2 kilogram pot of flowers. All right. So I'm going to have an angle. Looks like that. So this is force of tension 1 is pulling it this way. Force of tension 1. This is force of tension 2. Okay. Let's see. There is a hanging pot. Okay, I'm not going to try to draw that. There's my pot of gold. Okay, there's a hanging pot that is 6.2 kilograms. All right. Let's see. One of the wires is horizontal. The other is sloping. I meant to say sloping. Upward at an angle of 40 degrees. Okay. So this angle is 40 degrees. Okay. And attached to the ceiling. Find the tension of each wire. Okay? Find the tension of each wire. Okay. So in this type of problem, what you're going to actually have to do, let's see. There we go. All right, so we're actually going to have to find, so this is actually pulling it down, right? This is the force of gravity coming down. What's the force of gravity with this mass? So the force of gravity is equal to the mass times acceleration due to gravity. 60.76 newtons. Okay, now, oh, you can't see that. There we go. So the force on this hanging plant is 60.76 newtons. Okay? And what that means is the force, that's the force acting down on it, which means the tension up here, guess what that's going to be? All right. And actually, I drew the arrow wrong. My bad. 60.76. Okay, so the force of gravity has to equal the force going up, the tension, because the plant's not moving. It's not going up, right? It's just stationary. So the gravity pulling down is going to equal the tension pulling up. Does that make sense? All right, can I solve for my hypotenuse here?
Yeah.
Okay, so opposite and hypotenuse. So sine of 40 is equal to the opposite over hypotenuse. Okay. So what's my force of tension 2? What's my hypotenuse equal out to be? 94.5. Okay. And so that's my force tension 2. Okay. 94.5. Now, question for you guys. It's not moving once again. So my y due to gravity had to equal my y due to tension. So my force of tension this way has to equal my force of tension in the x direction. Okay, so what?
That's pretty easy.
That's not bad. So the force of tension going this way has to equal the force of tension going that way. Okay, so you can use tangent, or you can use Pythagoras. I'm going to use tangent. So the tangent of 40 is equal to the opposite over adjacent. Okay. And what's the adjacent x? Say that one more time. 72.4. 72.4. Does that make sense? Yes.
2 newtons have directions and magnitudes. Do I need to put like
Nope.
names?
Nope. Great question. Does that make sense? That's all we have for the chapter. Outside of that, we just got some practice. Okay. Try this one. Okay. Try 31, and then we'll be done. All right. Try it out. All right. A 1.84 kilogram bag of clothespin. This is probably the hardest problem you'll see for tension. All right. 1.84 kilogram bag of clothespin hangs in the middle of a clothesline, causing it to sag at 3.5 degrees. Find the tension in the clothesline. So what? Yeah. So you got to think of the force of gravity pulling down on the object, but it's being distributed over two strings, right? It's being distributed evenly between the two strings. Yes.
So on this string, the only thing pulling it down is this now. Okay, so the other thing is the force of gravity going down and tension going up. Okay, so they have to match each other because this is not moving. Theoretically. Yeah. Yeah. You would do
This is by the force of gravity by 2, so if there's 2 strings.
So the force of gravity would just fall.
Correct. I'm just wait till the end. That doesn't really and then define concept of final.
Yeah, that's also. I'm curious about you see the like last.
Because it wasn't equally like.
So,
There's the same angle, the last one's like a.
Yes.
both of these.
But still, we didn't know like the.
What?
Even though there were two
Yeah.
strings on
Strings,
it, that wasn't that the strings are different. Because looking at this, there would still be a force of gravity. That's where. On the other hand, they know that like the horizontal string.
I see what you're saying, because both are connected to it. But this, you're only focusing on this mass.
So, Mr. Bowers.
Yeah.
So for this one, we would divide that by 2.
Absolutely.
So why didn't we do that?
Because
There were 2 strings connected to it.
they weren't equally distributed.
So like why?
At this, so let me show you real quick. So theta is equal to theta.
Yeah.
Right? At the last one, we came in at an angle, so the weights, like the angles didn't equal out. So we couldn't equally distribute the weight.
Wouldn't there still be some like force of gravity on the horizontal one? Or no?
Tension? No.
Is there any horizontal?
Horizontal tension. Theoretically, yeah. Like you're.
I guess so, yeah.
So yeah, you can solve for x. If you wanted to. Okay, so in this problem, okay, find the tension of the clothesline. So the angle is 3.5, right? 3.5 on both sides. Did we find the force due to gravity?
9.6, but that's not. But that's for.
Yeah.
So 18.03, I think I heard. Okay. So that's the force of gravity. Now, since it's being equally distributed between the two lines,
Oh my goodness.
9.016.
so 9.016 on this side, 9.016. Those two equal out because they're both pulling it, right? So these two forces going up have to equal my force going down. Is that correct? They do. Okay, so we're good. All right, so all I got to do is solve for my hypotenuse.
So the sine of 3.5.
Oh, this is easy.
So the sine of 3.5 is equal to the opposite over my hypotenuse. What was it? 1.47?
Am I?
Wait, 147?
147.68.
147 newtons.
Would that just be the entire answer?
Find the tension of clothesline. That would be the first answer.
Okay.
At what sag angle will the tension of the clothesline have a magnitude of 175? Okay. Well, 100, at what sag angle will it be 175?
So to do this, do the opposite side.
So if this is 175, and I already know my angle there, how can I solve for my angle?
Opposite side.
Reverse side. Yes.
For A, does it matter when you split the forces? Because I didn't divide my gravity force by 2, but once I found the tension, I divided that force I got there by 2.
Do you guys still get the same answer?
I got 145, which that was because of the same thing.
Then you can do it either way. Whatever way makes most sense. 2.95? Is that what everybody's getting?
Yeah.
Beautiful. That's tension. That's the chapter.
I feel like that was easy. Yeah, somehow that was everything else is kind of.
I feel like the part that throws me off is the sum.
That kind of makes sense.
So wait, so it was 9.016, so we got 175
So the magnitude of the pole is 175.
Okay, so sorry, I zoned out. So like we got 147.7 newtons for part A.
For part A, yeah.
Okay, my bad. I was like, what?
Yeah.
Like,
Yeah.
my bad.
No, you're good. Yeah, inclined planes was the hardest part. Then we get into friction. And friction is just solve the coefficient force. Curves. Eventually we'll get there. We'll talk about kinetic energy, static energy.
So that's the tension of the entire clothesline, which is 394.
So we have 147, so that would be the tension of the entire string is what you're trying to solve for?
Like the entire time.
Yeah, that would be total.
Yeah,
So
well, I
we're
use
looking
that
for
first
the
and then I drive off
entire,
the wall.
but if we're just looking for here to here, the tension of this, it has to equal the tension of that.
So what was this asking for?
Find the tension of the clothesline, so
So
find for T.
Oh, okay, fine for 2. And then, if it was not in the middle, like it was like 1/3 of the way over.
That gets a little bit harder. We're not gonna do that.
Okay.
Because then you have weight distribution and
I need physics 2.
yeah.
Well, I'm assuming this.
Well, actually, that's going to be physics C. That's physics 3. That'd be calculus derivatives. Yeah. Absolutely. Where are you planning on going? Oh, that's cool. Yeah. Are you already in the audience? When's it due? All right. Give me a little bit of time. I appreciate it.
I was gonna do it earlier, but
Yeah, for sure. I'll get that done
Do you want me to try to turn the projector?
if you want, if you can try.